Hello and welcome to NOV Live. I'm Michael Gaines and glad you are joining us today as we continue our ongoing conversation about technology and its impact in the energy industry and talk to subject matter experts to bring you additional insight and understanding as we look to further our understanding and conversation in this space. So thanks for joining us. And we are glad that you're here to have a conversation with us as well. So before we jump into today's conversation, always excited to have the pleasure of having Shelby Dumaine here to make sure that you are able to have that conversation to be a part of our today's program. So Shelby, welcome. Good to see you. And how you doing?
I'm doing great, Michael. And I do have to mention it, although I'm sure you wish I didn't, but happy birthday.
Oh man, I wish you didn't, but thank you. That's okay. No problem. Thank you. Yeah. Happy to spend it here with everyone. So it's great.
Absolutely. And for those at home or at work watching this right now, there's a couple different ways that you can get involved in the show. The first and maybe the easiest is by commenting below. So if you have a question for us at any point, or for our really great guests that we have coming up, if you have any questions you'd like to ask them, go ahead and comment them throughout the show. As the questions come in, go ahead in your mind, go ahead and comment them, and we will get to a Q&A at the end. I'm watching the comments during the entire live broadcast, so I'll be making sure to get to as many as we possibly can. And then say after the show, if you had another question, maybe you wanted to follow up on some information, or even let us know a topic that you'd like us to cover on a future episode, you can get in contact with us a couple different ways. So the first is that you can email us at socialmedia@nov.com. You can just send us a quick message there, and we will answer you, and we love seeing those. And then the other way you can get in contact with us, again, I feel like I always say it, but it's my favorite way, is through our phone comment line. So you can give us a call, leave a voicemail, stay anonymous, or let us know your name and maybe even where you work. And that number is on the screen now. It's country code +1 346 223 4799. So we'd love to hear from you. I love that. I love hearing the voices of our viewers is always really, really great. And so that's all the different ways that you can send us in your comments and questions. And now is the segment on the show where we ask you a question. So it is time for Rig Geek Post of the Week.
Rig Geek's Post of the Week.
All right, so we got a good one. And as always, this Rig Geek question is a little bit of a hint of what we're going to talk about in the show when we bring in our guests. So today's question, which we'll put up on the screen, is how fast can large diameter fiberglass pipe be put together using the latest in joint technology? So if you think you know how quickly the fiberglass pipe can be put together, go ahead and comment below. Or even if you think you have a guess of about how long that takes, go ahead and comment that. And then at the end of the show, we will be revealing the answer and seeing how many of our Rig Geeks got that question right. So that's it for Rig Geek and how to get involved in the show. So I'll throw it back to you, Michael.
All right. Sounds good. Man, I love that. So I made sure that I did not find out the answer. So I'm just for posterity and have it on the record, I'm just going to guess that I'm just going to say at 90 seconds. I'm going to say 90 seconds is fast. Maybe I'm being overly optimistic. So we'll see. Maybe I'll be surprised. So with that, yeah, we'll go ahead and jump into our main conversation today. I actually was looking at some of the comments. So I see someone's asking, what's today's topic? And great timing in your question. We're actually talking about large diameter composite pipeline solutions with a focus on efficient water transfer and what that looks like. So definitely an interesting topic, especially if you're familiar with fiberglass technologies. And if you're not, then great timing, because that's what we're going to be talking about today. So I want to go ahead and bring in our guests. We have Chris. We actually have Chris Makselon, who is the Vice President of Strategy and Global Market Growth, and he's joining us, as well as Monty Inglehart. He's the Vice President for Research and Development for chemical industrial. So to both of you guys, thanks for joining us today on NOV Live.
Yeah, thanks. Good morning.
Thanks
Good
for
morning.
having me.
All right, so we're going to jump in, and Chris, we'll actually start with you. So, I mentioned fiberglass systems. Of course, the name is a little bit descriptive, so there's not history there, but I think there are some capabilities and areas that fiberglass systems plays in that folks might not be familiar with. So, could you give us maybe just a quick, 30-second run through of who Fiberglass Systems is and what you guys do?
Yeah, sure thing. We're the leading worldwide manufacturer of fiberglass reinforced epoxy pipe products. And we've got about over 65 years of composite manufacturing experience and a global footprint of manufacturing sites to service the various industries. Our products are mainly used in oil and gas applications, onshore production, but also marine and offshore projects such as production platforms, FPSOs, things of that nature, shipping container ships, and also in the chemical industrial business, food processing plants, wastewater treatment facilities, pharmaceutical plants, things of that nature. And one of the other pretty popular uses for fiberglass pipes that many people aren't aware of is even in fuel handling applications, where there's a pretty high chance that when you go to fuel up your vehicle at the local gas station, the fuel is actually running through fiberglass pipe and is stored underground in fiberglass storage tanks as well.
Okay, so you mentioned a phrase, and of course we saw some imagery to kind of help put more or less kind of a face with a name in a sense. But you mentioned fiberglass reinforced epoxy earlier, and so when you're talking about that, especially with fiberglass reinforced epoxy pipes, what does that actually look like? Can you give us just some tangible examples? Because I've heard the phrase myself many times. I know others have as well. What does that look like?
Sure thing. Yeah, most commonly it's referred to as fiberglass pipe or composite pipe, and it's pipes that use glass fibers as the main structural reinforcement to provide the strength for the pipe itself. And those fibers are typically encapsulated in an epoxy matrix that protects that reinforcement while the products are in service. Traditionally, these types of products were available in discrete joints, and the joints are brought out to location and either bonded together with glues and adhesives or threaded together with mechanical joints. But here in the last decade or so, you start seeing the technology evolving into continuous length versions, spoolable versions that allow you to bring out long lengths of this product into the field and just deploy it and install it.
Okay. So for those that may have just joined our conversation, we are talking about fiberglass, you're talking about large diameter composite pipeline solutions from NOV, and specifically how that plays into the water transfer space. So if you have questions about fiberglass reinforced pipe or anything in that realm, we have two experts here who are ready to take your questions. So if you're holding back thinking maybe my question's too hard, or I don't know feel free, dive in. That's why we have these conversations. We really like having some good technical conversations here. That's why we have the show. So certainly feel free for jump in. And as Shelby said at the top of the show, we'll try to get as many of those questions in as possible. So maybe as a quick follow-up to you, Chris, there are certainly many solutions and tools that can be used when you're looking at fiberglass reinforced pipe, especially when you're looking at conventional solutions such as steel. So why do operators, why do companies choose the fiberglass solution as we talking about, like for instance with NOV, versus maybe a steel solution that is maybe something that they're maybe used to hearing or seeing? Why would they choose the fiberglass route?
Sure. The first reason, and usually the main reason, is corrosion resistance, right? The fiberglass and epoxy materials that we use are highly resistant to many corrosive environments. And in these produced water handling systems, much of the water is also very highly corrosive. So that's usually the main reason. Another reason is the lightweight nature of the product. Because it's composite and we engineer the designs of the pipe to optimize performance, they're usually much lighter than the alternatives, maybe in some cases as high as a third of the weight of a steel alternative. Associated with that lightweight nature is also just the speed of installation. We'll be talking a little bit more about the joints as we get into this, but it's not uncommon for these joints to allow for these quick, reliable installations, to where you have, in the case of Super Seal Key Lock, a joint may be going together in 5 to 10 minutes, or in the case of spoolable products, you're rolling out 6,000 feet of pipe without a joint at all. So you can imagine how quickly that type of installation can go. And then one of the other reasons too, in these transfer systems, water transfer systems, efficiency is key. And with the composite materials, you also have a smoother ID on the product, so your pressure drop and friction losses tend to be less as well.
So then maybe we'll pivot over to you, Monty. Give Chris a quick break. Can you talk more about some of the technology and developments that have really gone into the fiberglass pipe offerings, especially when we're looking at expanding capabilities of the product? I know that's been a strategic focus for you and others in the team.
Sure. What this product's actually based on is an innovation taking our proven bond strand key lock product. So the product's been around for almost 40 years, but it's always had some shortcomings, and one of those was its ability to go to higher and higher pressures. There were some limitations to it, and so one of the things that we were able to do in these innovations is we were able to make some adjustments to the joint that allowed us to separate kind of the seal area and the locking area into two different diameters, and that allowed us to not only handle some of the shortcomings that we had previously, but it allowed us to increase the pressure carrying capability of the joint tremendously, as well as some of the flaws that we had when we had to take the joint apart and stuff like that. So it was some improvements on it. We actually have a patent pending on the design, and so some are pretty excited about, and the pressure limitations are through the roof, and so we're dramatically increasing the capabilities of this product.
So one of the benefits of conversations like this with NOV Live is we get folks like you, Monty, in the hot seat, who love to live, breathe, and talk about these things, especially from an engineering and specific standpoint. So maybe you can unpack a little more for folks like myself who are always curious about how does this work? So can we talk a little bit about the key lock joint? How does that work, and can you unpack that a little more for folks that are watching?
Sure. So one of the challenges we had in our key lock product is the O-ring was always at the same diameter as the sealing area. So if you see in that graphic right there, you can see that the locking keys, those are nylon rods, and they mechanically lock the joint together. And so what we've been able to do is we separated the O-ring seal from that same diameter. And so, the biggest challenge we ever had is if you build, say, a 16-inch pipe, but the joint on it is the equivalent of an 18-inch diameter. And so you actually have to put in an 18-inch joint for the equivalent to hold a 16-inch pipe. And that just scaled tremendously as you went in higher and higher pressure. With this new innovation, by separating that, we can maintain the sealing diameter at a much smaller diameter. And so the joint doesn't need to be designed for a significantly larger joint than the pipe. And so if you see in that graphic right there, when you assemble it together, the O-ring just passes all those locking keys without even contacting it. And then there's just one compression when you seal it. And then there's a little transition between the two, and that stops the joint's forward movement, and those keyholes are lined up. And then you just insert the keys. It makes the joint very rapid and goes together very quickly.
Okay. So then that helps me understand a little more. And I really didn't know. So understanding the key lock advantage in a word. So then Chris, maybe I'll pivot back over to you. So kind of knowing that and understanding, what it is, how it works, and how it's applied. How do you translate that into potential benefit for use across the industry? What does that look like?
Sure, absolutely. Monty touched on it. It allows for larger diameters and higher pressures. So it expands the product offering envelope for, applications where, the design is scalable. So based on the, volumes of water that needs to be moved and the size of these infrastructure projects, we can actually scale that to diameters and pressure ratings that allow end users to design their systems around the product. The consistency of the joint and the speed of installation and the quality that's associated with it. Very little human element associated with assembling the joint, so goes together easy and consistently. So that's another key thing when end users are going to commission their systems and they're doing their hydro tests. Very high success rate on these joints. Very little joint failure in this type of application.
So it's funny because the feature is called key lock, but I mean when you look at it, it seems like key lock's actually unlike its name, unlocking opportunity to sort of move out of the status quo, kind of into a space that really hasn't been able to be taken advantage of before.
Absolutely. Like what you're seeing is that, with the advantages of the key lock product and the scalability of it, engineers that are designing these water handling systems are no longer limited by the materials they're choosing, especially when you start considering things like higher temperature and even hydrocarbon content. That's the beauty of the fiberglass key lock system, is that the pressure ratings are at max temperature and with hydrocarbons in the fluid stream as well, without any derating necessary. So this gives them the opportunity to think outside the box and really use novel approaches for designing these systems. And then once they design these systems, they also get the added benefits of the speed of installation. You're talking about much shorter times on location, less manpower, things of that nature.
So if you are watching our conversation today, we're talking about offerings from NOV's Fiberglass systems team, specifically around large diameter composite pipeline solutions and with respect to efficient water transfer. So if you have questions on fiberglass pipe or capabilities, or anything of that nature, feel free to put your comment in the chat box, whether you're watching us on LinkedIn, Facebook, or YouTube, and we'll try to get to as many questions as possible. I see, actually, I'm looking over in the comment section, outside of seeing all the great countries that are represented, which I'd like to visit. It looks like we're also getting a lot of great questions in the comment section. So feel free to keep those coming, and we'll try to get some rapid fire questions over to Chris and Monty. So Chris, just maybe one more for you from me before we transition to some of the Q&A. How are you seeing the really response or the uptake in the increase in the features, the key lock, the whole package? How are you seeing that translate into projects in the field? Are you and your team seeing an uptake there?
Absolutely. We're seeing tremendous success with the key lock product, as Monty mentioned it, with the new developments and the recent introduction into the oil and gas segment. We've got several large infrastructure projects that are underway. We're expecting that over 1 million feet of this pipe will be installed just this year alone. Mm-hmm. And the beauty of the key lock system is that it also just complements our entire product line. Actually, you can see it in the video here. The darker pipe at the top of the screen is the actual key lock, but the other section of pipe there that you see that's in yellow is actually our smaller diameter 10-inch Star Super Seal product that's used for some of the well connects off the main trunk line. So we now have the opportunity or the ability to offer end users a scalable system for these water handling projects, regardless of the diameter, starting at 2-inch all the way up to 40-inch, based on the volumes that they need to move and the needs and capacity of their systems. So, like I said, we're seeing tremendous success with this product.
Right.
In these,
No,
types of
great.
projects.
Yeah, no, absolutely. And it seems like it. I mean, even for someone who, I certainly don't have the experience like you, Chris and Monty, but even just in our brief conversation, it seems pretty evident, the advantages, the benefits, and how this could really help, operations, especially for someone that's looking to maybe move from, a conventional steel over to a composite solution. So that's really intriguing, and I appreciate the insight. I would like to be able to give our viewers some insight, and that in the form of getting some of their questions answered. So we're going to go ahead and bring in Shelby Dumaine to get some of the questions from viewers over to you, Chris and Monty. And Shelby, it looks like there's been quite a few questions rolling in. So that's great.
Absolutely. I love to see it. Love to see from our viewers. So we're going to, some of these might be a little bit more rapid fire. So we'll try to get through as many of those questions as we can. The first one comes from Sashi on LinkedIn, and he's wondering, is there a possibility to include any sensors along with fiberglass systems?
Yes.
I'd be happy to handle that. There is no problem handling sensors beyond the fact it has to survive our manufacturing. And so one of the challenges is a lot of times those sensors have to be added after manufacturing. We thermally cure our products, and so that can usually be incredibly hard on the sensors, as well as going through the entire manufacturing operation. So sensors can be added, but they're usually a post-manufacturing process, and that naturally adds cost. So, but they can be done.
Mm-hmm. I think speaking on about the manufacturing process, we did get a question kind of early on in the show, wondering, they were wondering what do you see as the future of manufacturing in this area with pipes and composite pipelines?
So we have the capability of manufacturing the Star Super Seal key lock out of our Southeast Asia facility, and we're also in process of expanding capabilities here domestically as well in North America. But as I mentioned in the start, we have manufacturing capabilities around the world, strategically located to service these, the high activity areas where these types of products are used. So we've got a great support system in place as well to not only manufacture the products, but also ensure successful installations as well.
Excellent. So Chris, we had another Chris send in a question. So Christopher on LinkedIn was wondering what kind of inspection is done on the GRE pipe or maybe any of the other pipelines?
Sure. Most commonly, it's routine hydro tests, integrity tests with the composites. You don't have the capability of running smart pigs like you might with traditional steel, but integrity test is the most common that's used for monitoring long-term performance.
Mm-hmm. Gotcha. And then we also got a question kind of wondering the differences between GRE piping and fiberglass piping. So they made the comment that both are used in the offshore industry, but could you talk about, either of you, could you talk about the differences between those two pipes?
Sure. So GRE and fiberglass are somewhat used synonymously, oftentimes in the way we speak, but in reality, GRE is specific to an epoxy reinforced composite. Fiberglass itself covers a multitude of different systems, and so they're all manufactured principally with glass fibers. Some can be done with carbon fibers, but you get a variety in the marine offshore of the matrix system, which is either epoxy, vinyl ester, and sometimes even phenolic systems.
Mm-hmm. Gotcha. And that Christopher also asked another question, wondering, is it advisable to join by elimination? And if so, is that reliable, or what do you think about that? Mm-hmm.
So depending on the applications, we offer some products that do are joined together with a laminate system. But it typically does the applications and sizes and pressure classes typically dictate which joint is the most effective, both from a performance standpoint and a cost standpoint for specific projects.
If I could just follow up quickly, one of the challenges with lamination is it's slow and messy. You're basically building a coupling on site. It's an effective joint. Nothing is particularly wrong with it. It's just a slow and costly joint. One of the advantages of the key lock is the speed. If you were to do the same size line in a lamination joint, you're doing orders of magnitude slower installation rates.
Mm-hmm. Understood. And kind of some of those rapid fire, like I had mentioned. So we also got this question from Jeff on LinkedIn, and he's wondering what the high temp is. I assume he means what the kind of threshold of high temperatures that it can withstand. Could you speak to that, or if we can say that on air?
Sure. No, epoxy is very commonly designed throughout the world for epoxy up to 200 degrees Fahrenheit. We do have design capabilities up to 250 degrees Fahrenheit. That is typically about where epoxies top out. Vinyl esters are usually lower. Those are typically about 150 at most. And oftentimes are really designed for room temperature services.
Excellent. And so we had some other questions. We had several about the different size range or diameter sizes, which I know y'all touched on already. But we did get one other question from William, kind of along maybe those same lines about, do you anticipate going any larger than a 40-inch in diameter?
Sure. So in regards to the mechanical key lock, right now our maximum designs are at 40-inch. We have capabilities of manufacturing that up into, I believe currently it's either 60-inch or 72-inch, I believe 60-inch. If we needed to. The challenge is aligning joints to that size. So as a company as a whole, we can do as high as 102-inch, but then that is a O-ring bell restrained joint design. So we can do larger sizes, but for the mechanical of the key lock, we're limited at 40-inch.
Gotcha. That makes sense. And before we kind of close out audience Q&A and move on to Rig Geeks and whatnot, we did get this last one, which I kind of liked. It's kind of talking about maybe some other products that we've either talked about on the show or talked about here at NOV. And it is a little bit of a longer one, so save the longer ones for the end. But Ron was wondering, are there other applications like gathering systems that you see advantages of integrating multiple product lines, such as key lock and the spoolable products, like FiberSpar? And if so, are your connections designed to transition from multiple products and diameters, or could you talk a little bit on that?
Sure, absolutely. And the video snippet we showed earlier is a prime example of that. That was actually two of our products, both the Super Seal Key Lock and the Star Super Seal, that are different joint technologies that were used on the same project. And I think that's the beauty of our product offering and our entire line is that we can scale this to any size and use either spoolable, jointed, different joint technologies depending on size and pressure ratings. And there are transitions to go from the fiberglass to the different joint technologies, but also from the fiberglass to existing systems, whether it be transitions to flanges or threaded connections at the wellheads and things of that nature.
Wow. So this has been really, really interesting. I mean, these are some of my, speaking selfishly, some of my most favorite conversations when we could just throw everything in the kitchen sink at you guys and I don't see a bead of sweat. I mean, this has been really, really insightful and really understanding the value that the advancement in composite piping solutions has really had. And certainly the teams that are behind the scenes that you guys are kind of representing, I know have spent quite a bit of time, collaboration with customers, testing out at our test facilities, the whole nine in bringing these solutions. So really appreciate the insight. So Chris, for those that are looking to get some more insight on the opportunities and capabilities that we have, what are some of the ways we like to direct folks to get that insight?
Sure. First is go to our website, and a lot of information, product literature, catalogs and stuff are available for download there. Also through our LinkedIn page, we have an affiliated web page for fiberglass systems. And those are probably the best ways to get some information, or feel free to email us.
Great.
Email me directly or us at Fiberglass Systems.
Okay, excellent. Yeah, we'll certainly look forward to that. So I've been having a conversation with Chris Makselon, the Vice President of Strategy and Global Market Growth, and Monty Inglehart, the Vice President of Research and Development for Chemical Industrial. So to both of you guys, thank you so much for lending us your time, expertise, and joining our conversation today. Really appreciate it.
Sure. Thank you. Appreciate it. Happy birthday.
Oh,
Thanks.
Thank you. Thank you. All right, Shelby. Well, we're going to go ahead and reveal the answer to our Rig Geek post of the week we had at the top of the show. I may have been just terribly off, but let's put the question up again. I said 90 seconds. I think my brain is like way in the future possibly, but who knows? So what was the question? And let's put the answer up.
Absolutely. So that question was, how fast can large diameter fiberglass pipe be put together using the latest in joint technology? And I will say it's a good thing the camera wasn't on me when you guessed, because I was going, oh man, all good.
Story of my life. It's okay.
We love all of the guesses. I love seeing everyone in the comments putting in their guesses and getting their answers in. And so we will reveal the answer now. So large diameter fiberglass pipe can be put together in approximately 5 minutes per joint. Yeah, so
5 minutes.
Man,
I need to get with Monty. We got to get down to my 90 seconds. Maybe I need to take him out to lunch or something. But no, that's great. And I know for sure that is way like light years faster than when you're looking at a conventional way of putting pipe together outside of fiberglass pipe. So yeah, no, that's really cool.
Yeah, they call it a win-win-win, because you're saving money, time, and you're able to be much more efficient. So definitely a three-way win there.
Yeah, no, that's good. Awesome. Well, thanks, Shelby. That was really great. Appreciate it. Thank you all for watching and for all the questions that you submitted. Again, we love to have ongoing conversation and dialogue with you. So even after the live broadcast, if there are questions that you have, feel free to put them in the comment section on this post, and we'll be sure to have Chris or Monty or others from the team reach out to you. So on behalf of everyone here at NOV, thanks for watching and for listening, and we look forward to talking to you next time.